In this module, we'll talk more about center, and instead of eyeballing it and seeing about where the center looks like, we'll actually use technical, math ways to calculate it. So it starts out here. Recall that when we describe the distribution of a quantitative variable, we describe the overall pattern, which includes the shape, center, and spread, and deviations from the pattern, which of course we call outliers, as we saw in previous modules. In our previous discussion of patterns and quantitative data, we identified a typical value in a distribution. We used the single value of the variable to represent the entire group. That was the informal way of finding the center. But today we're going to talk about a few different ways to find measures of center and when you would want to use one versus another. In measure of center, we focus on describing the center of a distribution more precisely. So here we have a nice little graphic of kind of the order that we would do things if we were doing a statistical study and we wanted to graph things and kind of make them clear for the reader. The first thing would be in this yellow rectangle here. It says, graph the distribution of a quantitative variable. So you would get all your data, kind of compile it into a list and make either a dot plot or a histogram or something. And then from there, you want to describe a few things. First, the overall pattern. So what is the shape? Is it a bell-shaped curve? Is it kind of a right distribution, a left distribution? What's the center? That one, yeah, so far we've only had a way of eyeballing it, but now we'll have an actual way to measure it. And then the spread, how far left, how far right does it go? What are the x values on the x-axis that it falls under? And then also you want to find deviations from the pattern, which we call outliers. What are ones that are pretty far away, either much smaller than most of the values or much larger? And we'll get more into that in the future. How far away would it have to be in order to actually qualify as an outlier? So today we'll talk about two different ways of measuring the center. First, the mean. So that, you might have heard that name, and I'm sure you've seen it before. It's just the regular way that we average out a few things, like exam scores. So if you've taken 3 exams so far and you know your scores on those, and you want to know, what do I have to get on my 4th exam to average, a passing grade in the class, that kind of thing, that's what we talk about when we talk about mean. The mean is the average, so it's just another word for average. That's the one we see most often. But you'll see the symbol for it. It's an X with a bar over it. So if you ever see that in math and in calculations, you'll know that they're talking about mean. And then that symbol right there, we call it X bar, just because there's a bar above. To calculate the mean, as you've probably seen before in different ways, like in math, when you're trying to calculate your overall grade, to calculate the mean, we add the data values and divide by the number of data points. So, and we use a formula. I think that's one of the hardest things about math. Any math class, including statistics, all the new symbols you have to remember. So, X bar, the mean, is the sum of all the X values. So that symbol right there, they're trying to introduce new symbols. That one means sum, which means to add up the values. So you want to add up the values and then divide by the number of values. So just say n is the number of values. So this is kind of the formula, just using symbology, but they're saying the average would be the sum, which means to add of X values, and whatever the data points are, I guess. Sometimes they're sometimes they represent one thing, sometimes they represent another, and then divided by the n would be the number of values you have. Number of values. So it's just the most complicated way possible of saying something you already kind of knew how to do, I'm sure, from previous math classes, or just, calculating your grade in the class. So let's do an example just to make sure we really understand it. Let's find the mean of the set of 3 quiz scores. So someone took 3 quizzes in their class and they got 70% on one, 85% on another, and then 82% on another. In this situation, n is 3 because there are 3 quizzes that they've taken. The number of quizzes or the number of X values. In this case, X values are the quiz scores. We add the X values 70, 85, and 82 to get 237. We'll divide that by 3 to get a mean of 79. So in symbol form, let's see, we can write it like down here. They wrote kind of the workout. The average, X bar, means the average or the mean. It's the sum of all the X values, that new symbol that we've seen here, the sum, divided by n, which is the number of values. And we can write that out The sum of all the x values is 70 plus 85 plus 82 divided by n, which is 3. And then we'll add those values together before we divide. Once we add them together, we'll divide by 3, and then we get our average, 79. And I guess that sounds about right. If I made some math error in there, I'm sure I would have, it wouldn't make sense. 79 seems like it's about the average of those three scores, 70, 85, 82. I think the 70 kind of brought things down a little bit, but still a good overall score. Okay, now we'll talk about a little bit more complicated one because there are more values here. So kind of a similar thing, but instead of quizzes, we'll talk about homework. So suppose that Beth's homework scores are 70, 80, 80, 80, 85, 86, 90, 90, 95. So it's nice that they put them in order from lowest to highest. There's variability in her homework scores, but the mean represents her typical performance on homework. So we'll add all those together, and we have to count, I guess, how many there are, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 scores. So we'll write, our little formula, the x bar, which is the mean or the average. It's all those values added together, 70 plus 80 plus 80 plus 80 plus 85, 86, 90, 90, 95, all that divided by 9. We add together first, and then we divide by 9, and we get 84 in this case. So from this viewpoint, the mean is the fair share measure of center. So it wouldn't be just, it looks like that's about the average score, like we've been doing when we look at dot plots. This is actually an exact measurement of center. But we'll see sometimes that's not, and depending on the situation, what we're talking about, in this case, homework scores, but in other cases, maybe average wouldn't help much, especially if there are outliers. We'll see more about that. But notice, however, that Beth did not actually make an 84 on any assignment. So she had a few that were lower than 84. She had 70, 80, 80, 80. The mean does not give us information about any individual homework scores or about how the homework scores vary. It only gives us a sense of her performance by averaging the values all across the assignments. So here we have a dot plot measuring with all the values that were actually homework scores of hers plus the mean. So you notice that there are dots. There's a dot at 70, there's 3 dots at 80, because we did see that she got 80% on 3 different homeworks. And then there was 85 and 86, 2 90s and 1 95. But the mean is somewhere in the middle, and there are no dots there because she didn't actually receive an 84% on any of those. But still, the mean, it still represents kind of a measure of center, even though there are no values necessarily in this context that she actually received that. The mean is also referred to as the balancing point of a distribution. If we measure the distance between each data point and the mean, the distances are balanced on each side of the mean. So I guess all the scores that were lower than 84, if you think about all their distances from 84 put together, it's the same as all the distances from 84 of the ones that are larger, if that makes sense. So for example, a homework score of 95 is 11 points above the mean as shown. So in this picture you see 84 here, and then the 95 score she got here. They're 11 units away from each other. A homework score of 80 is 4 points below the mean. Down below in the table, we calculate the sum of the distances above and below the mean. So that means if I look at all the values that were below 84 that she received on homework, and I calculate all their distances from 84. So for example, there were 3 homework scores that were at 80%, which is 4 units away from the mean, 84. 4 plus 4 plus 4 plus this one way over here, 70 is 10 units away, no, 14 units away from our mean, 84. So we want 4 plus 4 plus 4, because that's the distances from 80 to 84, plus 14. 4 plus 4 plus 4 is 12, plus 14 is 26. So there's a total of 26 units of distance from the 4 dots to the left of the mean, smaller values. Let's see if that's the same over on the right. We had already said that 95 is 11 units away from 84, so we already know that distance. Plus these two are at 90, that's 6 units away from 84. But there are 2 of them, so we'll add 6 twice. They're each 6 units away. Here's a value that was at 86. 86 is 2 units away from our mean, 84. And I think there was one here at 85, if I remember right. That's only 1 unit away from our mean at 84. So what are all those added together? 11 and 6, 17, plus 6 is 23, plus 3 is 26, yep. So if you add up all the distances of those values that were smaller than the mean, and then you add up all the distances of those values that were larger, you get the same. So it is kind of a balancing point, I guess. Imagine scales. You kind of balanced all the values perfectly, sort of. And another way to think of it, if you would like, rather than the way we just did it, you can also view the distances below the mean as negative because you had to go a negative distance toward smaller values. And then the distances above the mean that were larger on the right as positive. When we add these signed distances together, we get 0. Because all the ones on the left would add up to negative 26 instead of, like we wrote, 26, plus the positive 26 from all those that were larger on the right. So that's just another way to think of it, I guess. That kind of makes it feel like it's a balance point like they talked about. Okay, now we'll talk about a different measure of center, median. So let's see, it says, the median is another way to identify a typical value. The median is the middle of the data when all the data values listed are in order. So kind of like the homework scores they gave us on that last example, they gave it to us from smallest to largest. If they either do that or the opposite, largest to smallest, then we can find the median pretty easily. The median divides the data into 2 equal-sized groups. There is as much data below the median as above it. So for example, the median homework score, like in those homework scores that she gave us previously, the same scores, the median would just be the one right in the middle. So in this case, there were, let's see, how many scores are here? 9, right? So if there were, you have 4, the first 4 on the left, 85 would be in the middle, and then there'd be 4 on the right. So in this case, 85 would be the median. Median, which is pretty close to our mean above the average. We got 84, right? So it's almost the same value, which kind of shows that they're both, seems like they're fairly good measures of center. So the median score is 85, and this is the center score. There are 4 homework scores below 85 and 4 homework scores above 85. For this data set, the median was one of the homework scores. This will not always be the case. So like the mean, the median does not give us information about any individual homework scores or about how the homework scores will vary. It only gives us a sense of best performance by locating a value that is in the middle of all the actual scores. So we'll kind of talk more about this as this module goes on. When would one be better than the other? When would you probably want to use a median? When would you want to use a mean?